Hey everyone, so today we're going to be checking out a hackathon project that I worked on a couple weeks ago. The project itself is a bot that plays the game Set, and in this video we're going to go over three things. One, what is Set? What's the game that it's playing? Two, what is the bot doing? Let's look at the output of the bot, let's see the bot in action. And then three, how does the bot work? We can go over some of the hardware, and then we can walk through a bit of the software. Obviously, I'll link the source code so you guys can get as in-depth with it as you want. But with that, let's get started at checking out what the game itself is. Let's get into how the game is played. The game is played between 2 and 4 players, and the game is played without turns. So each of the players is sitting around a board of 12 cards, very much like this board of 12 cards, and looking for sets. Once you find a set, you yell set and pick up the cards, or show the other players, pick up the cards, and then replace those cards on the board. So there should always be 12 cards on the board, and it's a race to find valid sets. Now, what is a valid set? It's 3 cards where each of their 4 attributes are either all the same or all different. It's a little confusing, so let's first go over what a card's attribute is. There are 4 of them. There's color, so their cards could be red, cards could be green, cards could be purple. It's shape, cards can be an oval, a squiggle, or a diamond. The number of cards, this one is a 1, there's 2s, and there's 3s. And then there's interiors. You can have a solid, a blank, or a stripe. And so if we were looking at this board, we'd be looking for valid sets. There are 3 sets that you could have found on that board. This one is a valid set because the attribute of the numbers, those are all different. This one has a 2, a 3, a 1. The colors, those are also all different. Green, purple, red. The symbols, those are all different. Squiggle, diamond, oval. But the interiors are all the same. And so they're all 3 of them are blank. And so because all 4 of the attributes are either all the same or all different, it's a valid set. Here we have another one. Their colors are all different, but the shape, the number, and the interiors are all the same. So since all 4 of those attributes are either all the same or all different, it works. It's a valid set. And then the last one I'll show you here on the board. It's these 3. The green squiggles, there's 1 of them, and their interiors are different. So again, all 4 of their attributes are either all the same or all different. And if we were playing the game, I would say set and scoop these cards up. So with that, we know how the game works. Let's now check out what the bot does. Alrighty, so we're going to show the bot in action. As you can see, it's a webcam that's looking at a 12 card board, very similar to what we were looking at before. And over here, you can see the output of the camera. And so we're going to start it. And as you can see, what it's doing is 10 times a second, it is viewing the board, identifying the cards, and finding all the sets and reporting them. And so, as a little demo, I'm going to replace the cards, and you can see it work in real time. I wish there was more sets right now. Let's see. What can I remove? A lot of red cards. There we go. Well, that'll be about the demo, but you can see. You can do the whole deck. It's pretty fun. Alrighty, so now we're going to take a peek behind the curtain as to how this works, pretty briefly. So to start, we take the image, we turn it into a black and white image, and we apply a threshold to it, just setting anything that's gray or white to be black and anything that's black to be white. We do this so that we can find the overall shape of each card. Once we do this, we look for shapes that are roughly the size of a card. Threshold's pretty big, and with that we can find each individual card. And so this is the result that we get after that. We segment it down. Now it's a pretty small image. We find the edges of this card, and then we fit lines to these edges. There are some constraints on how long the line has to be and the thresholds, whatever. But as a result, we then compute the intersection of each of these lines. What we're looking for specifically are the corners, these four corners right here. We look for the four most extreme corners, so the furthest up, top right, top left, bottom right, and we assume that these are the four corners of our card. We have to do this because the card's edges are rounded, and this gets rid of that. Then once we have these four corners, we can de-skew the card. So here the card is a little skewed, it's a little rotated, and we transform the card so that it perfectly fits a rectangle that we're familiar with. And so we go through this process with each card, taking it, thresholding it, fitting lines to the edges, and transforming it into a perfect rectangle. Once we have our rectangle, we can now determine the shape and number of the card. So to do this, we again apply a threshold after we cut off the edges, and now we do a symbol match. So we try to match three different symbols, a diamond, a squiggle, and a oval, taken just from a capture from the same camera. As you can see in this example, we found a diamond, and we found it in the three areas that you would find a three symbol card to be. So as a result, after this, we know that it's a 3 diamond card. We don't know what color it is, that comes right here. And what we do to find the color is we look on the entire image, or this entire image, for colors that represent either red, green, or purple. And then there's a voting scheme to figure out which color it is. So this one, red, won. And the only thing we have left to do is find the interior. So to do that, we actually know where the symbol is. So we take a snippet out of the interior of the symbol, and we compare that to the median color of the card. The reason that we're doing this is that the difference between a striped interior and the edge, or like the corner of a normal card, is really slim. And so if we just looked at this based on like a universal value as opposed to the card as a whole, things like shadows and specific lighting can really trip you up. So for this one, we would see that the interior of the card is not very different than the mean or median of the card, and so it's probably a blank interior. Here's another one. This is an oval. Most of the votes for the symbol came in the center, and so probably an oval. It's green because green won out in our color voting. And then here's a better example. Actually, let's move this over, of the interior. So you can see that the interior is a little bit darker than the mean or median of the card as a whole. As a result, this is compared against some HSV thresholds, which are actually different for each color of card, but this would be determined to be a striped card. And so that part was definitely the hardest to do, but now it works pretty reliably. So this one is a purple card, and again striped. Purple is pretty easy to tell the interior. Other colors like red, it's very hard to do. And so again, we're going to do this for all 12 cards. And then we're going to get this. This is the labeled image, right? So we now know all the cards and where they are. And then we have to do a bit of computation to find the sets themselves. To do that, we treat it as if it's a 4-dimensional matrix, and we look for lines. So it's brute forced against all 12 cards, and it runs obviously pretty quickly. This is running on a medium end PC, and it's able to run 10 times a second. And that's basically how it does it. After that, you just draw lines between the centers of the cards that create sets, and you're off. All the code was written in Python using OpenCV. All the code I'll make public so you guys can check it out. But again, for a weekend project during my first hackathon, it was really fun, and definitely happy with the outcome. So appreciate you guys watching, and check it out, leave comments, do whatever you do. Appreciate it.